Now we start with kinetics of particle part 1, that is a topic in dynamics. We have studied the Newton's law, which is F is equal to ma, and if there are number of forces, suppose we have a body which is subjected by F1, F2, F3, so three forces on it. So summation of these forces is equal to the mass into the acceleration, mass of this body and the acceleration. So this is the Newton's law. And the D'Alembert's principle that we are going to use in this chapter states that summation of these forces minus this mass into acceleration terms gives you zero, uh, which gives zero resultant, which means that your body would be at rest. Now, how it works? Suppose this is the force F1, this is F2 and F3 acting on a body. So collectively, they will have they will cause a motion in this direction. Now, to encounter this motion and to maintain the state of equilibrium, what we do is we apply an equal and opposite force on the resultant. Suppose this is the resultant we have, this is the RF. So, an equal and opposite force is applied. This force is equal to the ma of Newton's law, which brings the body back to zero motion, that is at equilibrium. So this is D'Alembert's principle. We have discussed it in the introduction lecture also. Now, how we are going to use D'Alembert's principle? We have two kinds of motion, that is rectilinear motion and curvilinear motion. Now, for rectilinear motion, the case is similar to this. We have three forces F1, F2 and F3 acting on a body. They will cause a motion in this direction. So this will be your Fr, that is resultant force. And to counterbalance this motion or the effect of the forces, we apply an equal and opposite force, which is given by ma, and the body is brought back to equilibrium. Now, curvilinear motion is a little interesting here. Suppose this is the path that the body is going to follow because of these F1, F2 and F3 forces. So to counter this, we have to apply a resultant acceleration, but that resultant acceleration cannot be found directly. So what we find is we find a tangential component to the path. Suppose this is the path. So we find a tangential component which is given by mat, and we find a normal component at this point which is given by man. So by finding these two accelerations acting on the body, we can find the total resultant force which would be required to bring back the body in curvilinear motion into equilibrium. So this is how we are going to implement this D'Alembert's principle in our questions. Okay, now we have a sum based on the D'Alembert's principle. It says two blocks A and B with mass 10 kg and 28 kg separated by a distance of 12 meters. If the blocks start to move, find the time t when the collision happens, and the coefficient of frictions are given. For block A it is 0.25 and for block B it is 0.10. So this diagram is also given in the question, where the angle is 30 degree. This is block A, this is B. A is at 10. The weight of A is 10 kgs and B is 28 kgs. So using D'Alembert's principle, summation of Fy, the vertical forces is given here. This is what we have for our block A. So the weight, or for block B also we can do the same thing. The weight, that is mg, is this is the weight, right? So we have taken the sine and cos components. So we have resolved the weight into the x and y components. One component is mg sine theta and sine 30, and the other component is mg cos 30. a resultant of this will be acting on the block. So this is given by R here. The block is moving in downward direction. So mu R would be in upward direction, and it would be, mu for block A is 0.25 and for block B will be 0.1, and the reactional force, or the countering force MA would be in upward direction. So now summation Fy is given by R, which is in positive direction, minus mg cos 30, which is in downward direction, is equal to 0, or we can write R is equal to mg cos 30. So this is our equation number 1. Similarly, using D'Alembert's principle, we are going for summation of horizontal forces. So mg sin 30, this is in negative x direction, so this is negative, plus mu r, which is in positive direction, so plus mu r, plus ma, which is the counting force, is equal to 0. And by shuffling these things, we get A, that is acceleration, is equal to 9.81 into sin 30 minus mu cos 30, and this is the value of R, which we get from here, which is mg sin 30. Or we can substitute the values as well if required. So now, for block A, the value of mu is given to be 0.25. The acceleration is given by this formula. So just simply substituting the values, now we will remove these things. Substituting the values here, this will be 9.81 into this value would be sin 30, which is 1 by 2, minus mu is 0.25, and then cos 30. And when we calculate this value, we get acceleration of A, block A, is given by 2, is 2.781 meters per second square. Now for block B, similarly for block B, the value of coefficient of friction is given to us, which is 0.10. So again, using the same formula, which is same equation rather, this is equation number 2. So 9.81, again sin 30 minus mu is here 0.1 and cos 30. So when we calculate these values, we get the value of acceleration of block B as 4.055 meters per second. Now these are the accelerations of the block A and B. Now these blocks, after traveling some distance, will collide. So when the collision takes place, the distance traveled by block B would be 12 meters more than block A, because they are separated by 12 meters. So this is what we have written here. Distance traveled by B would be distance traveled by A plus 12 meters. And we have our formula, which is S is equal to UT plus half AT square. Now using this half AT square, now using this formula for both this case and this case, we get, taking that the initial velocities are 0, we get for this value we get half. Acceleration for block A is given by 2.781 into t square, and this is equal to, this is plus 12 of this value would be same as that of traveled by block B, which would be half into acceleration of block B would be, that is 0.0455 into t square, and when we calculate this value, we get the value of T, which is the only unknown in this equation. And T is given by 4.34 seconds. This question was asked in the university exam for 12 marks, and it was asked in May 2010. So it's a very important question, covers all the bases that we need for this particular topic.